Hi everybody, it's Mr. Mars, and I am giving you this short video to help you expand some skills and learn how to divide polynomials. The method that we're going to use is going to be called the synthetic division method. I am going to have a video soon that is showing another way that's not synthetic division, but I always start with the things that are my favorite, and synthetic division is definitely my favorite. The first page of notes is actually kind of like a visual thing for you to go back and take a look at after I show you how to divide using synthetic division. I just want you to notice a couple things here. There is an important thing when it comes to using the synthetic division method, and that is that when you're dividing polynomials, the divisor has to be a binomial, and the exponent must be 1 and the coefficient should be 1. Those things are kind of important in order to be able to use this method. So let's go and try some examples. So we're going to start with the very first one here. Our variable is r, and our divisor is r minus 3. Notice that my coefficient is 1, and the exponent on this is also 1, so we can use it. What we are going to do is we're actually going to bring this number to this spot, and not only that, we're going to change the symbol on it. So if it's a -3, I'm going to bring over here a +3, and if this was a +3, I would have brought over a -3. So that's the first thing. The next thing I'm going to do is I'm actually going to look at all of the terms in the polynomial that I am dividing into. So I have r cubed is my first term, 6r squared is the second term, -21r is the third term, and our constant term is -18. But what I'm going to be writing down is actually the coefficients. For instance, this first term, the r cubed term, the coefficient is 1. The second term, the coefficient is 6. The third one, it's -21, and then my constant term is -18. So not only am I writing the coefficients down, but I am making sure to include any symbols that might be in front of them. The next step will be to bring down this first number and place it on the bottom. And then I'm going to take this first number and multiply it by 3. So 3 times 1 is 3, and I'm going to put that right here. Then I'm going to add that to the next number I'm bringing down. 6 plus 3 is 9. And then I get to do the same thing again. I multiply 3 by 9, which is 27. Combine that with -21, and I'm going to get -6, not -6. And then I'm going to multiply 3 times 6, that gives me 18. And then I'm going to combine these last two, and it's 0. Really interesting, right? This is something that's going to be really easy to do after you kind of get used to the steps. Now what we're going to do is we are going to label under our numbers. So I always start from the right and work to the left. The first number is what we call the remainder, so I usually put an r there. In this case, there's 0 remainder. The next number is going to represent the constant term. The next number is going to be our r term. And then the next one is r squared. If I had more, I would be going r cubed, r to the 4th power, r to the 5th power. And but I'm not, so that's all good. So now when I write this out, I'm going to say that if I were to divide my big polynomial by r minus 3, my answer would be r squared plus 9r plus 6. Now, I just want to remind you that basically what we're doing is we are breaking down this, this 4-term polynomial into 2 polynomials, right? Like basically if I am dividing it by r minus 3, that, and I get r squared plus 9r plus 6, I'm basically like rewriting this like r cubed plus 6r squared minus 21r minus 18 is equal to r minus 3 times r squared plus 9r plus 6. I kind of factored it, really. That would mean that r minus 3 is a factor of my original polynomial. So it's kind of cool. Let's try this again. So let's do the next one. Again, remember that you have to take this -5 and push it over here and make it a positive. Change the symbol. I have the numbers 1, -11, 22, and 40. Those are my coefficients and then my constant. I'm going to bring the 1 all the way down here, multiply 5 times it. 5 times 1 is 5. Combine with -11 to get -6. Multiply 5 times -6 to get -30. Combine that with 22 to get -8. Multiply 5 by -8 to get -40. I combine 40 with -40, and that's going to give me 0. So, as I am labeling, my remainder is 0. I have a constant term, I have an x term, and I have an x squared term. So if I were to write it out, x squared minus 6x minus 8 is what I would get if I divided my original 4-term polynomial by x minus 5. If someone were to ask me, is x minus 5 a factor of x cubed minus 11x squared plus 22x plus 40, I would say yes, I would. And the only thing that would make me not say yes is if I had something in the remainder spot. And so now we're going to look at some examples that end up having something in the remainder spot so you can see what to do if you have that issue. Be aware that if the polynomial you're dividing into doesn't have a term that steps down from the highest to lowest degree, you're going to need to put a placeholder in the spot. This next example is a great example for that. I have x to the 4th power plus 9 divided by x plus 3. This is going to be coming down into this spot, making it -3. Notice that there's a huge jump here if I'm talking about stepping down in exponent numbers. So degrees is basically how we would say that. X to the 4th plus 0x cubed plus 0x squared plus 0x plus 9 is basically the way to write that out if you want to know what you should be bringing down to put down here, because you can't just go right from a 4th degree all the way down to a 9 without putting placeholders in for all of the degrees as they step down. So this would look like 1, 0, 0, 0, 9. 4th power, 3rd power, 2nd power, 1st power, constant. Now we're just going to go through everything the way we normally do. 1 comes down here. -3 times 1 is -3. So that goes here. -3 times -3 is positive 9. Combine. -3 times 9 is -27. Combine. And then 3 times -27 is going to be positive 20, 40, 60, 81. Positive 81. And then I'm combining that with the 9 to get 90. So you would not think that this would be such a messy result, but it really is. Remember, this is the remainder, constant, x term, x squared term, and x cubed term. So my answer would be 1x cubed minus 3x squared plus 9x minus 27, and then I have a remainder. So I'm going to take that remainder and I'm going to put it on the top of a fraction, And what's going to go on the bottom of the fraction is my divisor, x plus 3. And this is the result from that last one. So you learned two things there. You learned about having to put all of those placeholders in there, and also what to do if you have a remainder. Looks like that. And that's okay. That would mean that x plus 3 is not a factor of x to the 4th power plus 9, but we can divide and express what the result is. Let's look at this last one. Plus 1 minus 1. I have 6, 5, so 1x to the 6th power plus 4x to the 5th power. I have to put a placeholder in for the 4th power, negative 2x to the 3rd power, 0x squared, 0x, 7. So just so you know what that looks like, x to the 6th plus 4x to the 5th plus 0x to the 4th minus 2x cubed plus 0x squared plus 0x plus 7. I took care of 6, 5, 4, 3, 2, 1, and then the constant. So that's where I got my 1, my 4, 0, negative 2, 0, 0, and 7. Now we got to do everything we keep doing. Bring down the 1. Negative 1 times 1 is negative 1. 4 combined with negative 1 is 3. Negative 1 times 3 is negative 3. 0 combined with negative 3 is negative 3. Negative 1 times negative 3 is positive 3. Combined with negative 2 is a 1. Negative 1 times 1 is negative 1. Combined with 0, negative 1. Negative 1 times negative 1 is positive 1. Combined with 0 is 1. Negative 1 times 1 is negative 1. Combined with 7 is 6. Holy Hannah. Lots of stuff going on there. Here is our remainder. Here is the constant. X, x squared, x cubed, x to the 4th, x to the 5th. Now I can write it all out. X to the 5th plus 3x to the 4th minus 3x cubed plus x squared minus x plus 1 plus my remainder 6 over x plus 1. It's a lot of stuff. X plus 1 is not a factor because it had a remainder, but it still looks beautiful. Synthetic division. I have a homework sheet posted that has 4 examples for you to try and submit back to me. So hope everybody's doing well. I miss you so much. And send messages if you have any questions or problems. Have a great day.